Alright, let's talk about oxidation numbers. They will be critical to the things that we're going to go on from here and do, so you need to be able to do this. Before I get started, a longtime fan of the channel has given me some feedback saying that the writing was too small, so I've tried to make the writing bigger here. I hope everybody appreciates that. Oxidation number is the charge on an atom in a compound would have if the electron pairs in the bonds belonged entirely to the more electronegative atoms. Blah blah blah. There's some rules. In any element, when not combined with atoms of a different element, the oxidation number is 0. Na 0, Cl2 here is 0. In a simple monoatomic ion, oxidation number is equal to its charge. Na plus would be +1, S minus 2 would be -2. Another thing you have to know is that the sum of the oxidation numbers for all the atoms in a formula must equal the charge on that molecule. And you'll understand, we're going to do a ton of examples down below. If you wanted to pause and sketch these down, these little rules, you can. I'm not sure it's necessary. As soon as you start doing these, you'll be able to snap them out. Oxygen is always going to be -2. Compounds, 1A metals are +1. Second column is +2. Aluminum is always going to be +3. Yes. Often here, the things in the second last column are -1. F is always going to be -1. O is almost always going to be -2. It's not always -2. There's a couple compounds where it'll be -1. H is almost always going to be +1. So let's do some examples here, and as I go, I will explain what I'm trying to do here. Okay, so N by itself, no charge, oxidation number here is 0. N2, no charge, the N's here are 0. N -3, oxidation number here is -3. Be +2, it's all by itself. Be, it takes the charge of the charge on the ion. Here I'm going to have a 0. Here I'm going to have a 0. Perfect. Now we can do all the ones that atoms that are by themselves. Now we're getting into some polyatomic ions. I know that K is in the first column. It's always going to be +1. O is pretty much always going to be -2. 3 times -2 is -6. I've got a +1 here. When I look at these numbers here, that's a total of -5. All the numbers here have to add to the charge on this molecule, which is 0. So if currently I'm at -5, N better be +5 so that I get a 0. Notice here, +1, +5, and then 3 -2's put me at the overall charge, which is 0. Now, something that you'll notice, NO3, everywhere NO3 goes, its oxidation numbers of the N and the O will be the same. So NO3 in this one will have the same oxidation numbers as here and as here. So note, sometimes when you've got one like this, if I go +5 and -2, NO3 has a kind of a charge of -1. NH4 has a charge of +1. So when I'm dealing with the NH4, I know it needs to be a +1 in the end. Each H is 1. There's 4 of them. It gives me +4. To hit +1 in the end, N better be -3. -2 +1. That's a -6. That's a +2. I need to get to a 0. That's going to be a 4. A -2, a +1 gives me -8, +3. To get to 0, looks like P better be a 5. Al, one of the rules up above is that it's always going to be plus 3, and we just did NO3 here. It's 5 and minus 2. Minus 2. This thing has a charge, this SO4 has a charge of minus 2. This is a charge of plus 1. We did it up here. It's going to be minus 3 and plus 1. SO4. I have 4 things at minus 2, gives me minus 8. I want to be at minus 2 in the end when I'm just looking at this little polyatomic ion, so it looks like the S better be a 6. I'm just going to keep on pounding these out. I got tons of them. Minus 2 plus 1, minus 14 plus 2. There's 2 CRs. Looks like each one of them better be a 6, so I hit 0 in the end. Minus 2 plus 1 minus 8. Still just plus 1. Looks like minus. Looks like MN's got to be a 7. Again, just so we're clear, these are the oxidation numbers that I'm writing directly below. This is kind of some rough work, so I'm doing some multiplying just to show you how I'm doing it. But the oxidation numbers, the actual answers are the row right underneath. Minus 2, that gives me a minus 6 because there's 3 of them. I need plus 6 over here. There's 2 of them. Each one's going to be plus 3. Minus 2, got to be plus 2. Minus 1, minus 2, gives me minus 2 here, gives me minus 4. Looks like U's got to be a 6 so that I can hit 0. Minus 2 plus 2, minus 2 plus 4, minus 4, got to be plus 4. Keep pounding these out. Lots of examples. Oh, 0. Minus 3, it's got to be the charge. Minus 2 plus 1. Minus 2 leaves me at minus 6. In the end, I have to hit minus 2, so it looks like C's got to be a 4. Minus 2 plus 1, that gives me minus 8, plus 1. Looks like the CL's got to be a minus 7. And that's an example where something in the second last column is not minus 1. Minus 2, which is minus 8. I need to be here. Looks like Mn is going to be a plus 7. Al is plus 3, right? Which leaves me at plus 6 over here, which means that each of these SO4s is got to be a minus 2 because there's 3 of them. Minus 2 leaves me with minus 8. Looks like the S has got to be a 6, and here I got a 0. So there, I know it's a little quick, but you can pause and rewind and go back and watch again. You can go up and take a look at the rules at the top, but I'm just following those rules. There's some ones that I always know, like H and O. I know what the overalls have to add up to be, like the charge, or if there's no charge, 0. And that can quickly lead me to the right answer.